A company provides a death benefit of 50,000 for each of its 1,000 employees. There's a 1.4% chance that any one employee will die next year, independent of all other employees. The company establishes a fund such that the probability is at least 0.99 that the fund will cover next year's benefits. Calculate using central limit theorem the smallest amount of money rounded to the nearest 50,000 that the company must put into the fund. Okay, so uh, let X be the number of employees that die. There's a 1.4% chance that any employee will die. So either an employee will die or not die. So this is binomial. X is binomial, the number of deaths. We're testing it for 1,000 employees, and the probability of death of each employee is 1.4%, so 0.014. Therefore, the expected value of X is NP. That's the expected value for binomial variable, equals 1,000 times 0.014 equals 14. And similarly, variance of binomial is NP times 1 minus P. NP is already determined to be 14, and 1 minus 0.014, and that is 13.804. Let Y be the payout, and you are paying 50,000 for each death. So since X is the number of deaths, so the payout will be 50,000 X, and the expected value of Y will be 50,000 times expected value of X. Here we are using the central limit theorem, equals 50,000 times 14 equals 700,000. So that's the mean of Y. The variance of Y, again by central limit theorem, will be 50,000 squared times variance of X equals 50,000 squared times 13.804 equals this 3451 with a bunch of zeros. And the standard deviation will be the square root of variance, so that's 185769. Now we have to find the smallest fund that is needed so that there is at least 0.99 probability that the fund will be sufficient to cover all the payout. And that means that we want 0.9, we are looking for 0.99 probability that the total payout is less than this amount. Okay, because now they said the probability should be at least 0.99, and you want to find the smallest fund. So we check that what fund we need for 0.99 probability, and for greater probability you would need greater fund. So the smallest fund that will work is the fund that will correspond to 0.99 probability, because that's the smallest probability in the range. Okay, so probability that the pay, so we want the payout, total payout. Remember, Y is the total payout. We want the total payout to be less than or equal to this fund that we have, the smallest fund amount that we have, and we want this probability to be equal to 0.99, and therefore we should be first trying to find the z-score that corresponds to 0.99. So from table, let's see. Okay, so 0.99. So if we look in the table, we're looking for a probability of 0.99. We see 0.9898 and 0.9901. So 0.9898 corresponds to 2.3, 2.32, and 0.9901 corresponds to 2.33. Okay. So 2.32 for 0.9898 and 2.33 for 0.9901. So we do the interpolation as usual, comes out to be 0.7. Therefore, z is equal to 2.327, corresponds to a cumulative probability of 0.99. So we have probability z is less than equal to 2.327 equals 0.99. Okay. So so that means now if you look at this equation, probability z is less than equal to 2.327 is 0.9, and then you look at this first equation, the probability y is less than equal to s is 0.99. So it means that in the z-score formula, this s corresponds to 2.327. So when z is equal to 2.327, y is equal to s. So this is the z-score formula, y minus mean of y over standard deviation of y. So when z is 2.327, y is the smallest amount. Okay. So the mean of y is the expected value of y, which we found above to be 700,000. The standard deviation was this 185,769. So when we do the algebra here, we get s is equal to 113. So basically, it's read as 1,132,284. So they said that you round to the nearest 50,000. That's what they said in the problem. Round to the nearest 50,000. So that means, okay, leave the 1 million aside, the remaining part is 132,000 something. So when you're rounding to the nearest 50,000, it means you can't have 132,000. You will have either 100,000 or 150,000. So the 132,000 is closer to 150,000 than it is to 100,000. Therefore, it will round to 1,150,000. And that is choice D. Okay.